Hello, and welcome to Glasgow Science Centre's Curious About Innovation Digital Science Festival. My name's Nina, and I'm the Planetarium Coordinator here at Glasgow Science Centre. Thanks to University of Strathclyde, we're shortly going to be joined by NASA engineers Miriam Sargusingh and Stephanie Walker, who are going to be telling us a little bit about the work being done in low Earth orbit aboard the International Space Station and how that work is helping us explore further into space. Afterwards, we're going to open the digital floor for some questions. You can ask those questions by popping them into the YouTube comments, and my fantastic producer, Abby, will send them over to us. We'll start the talks now, so get comfortable, and we'll see you in just under half an hour.
Hello, I am Stephanie Walker, and I am a Life Support Systems Engineer at NASA Johnson Space Center. I'm here to talk about the International Space Station. So the International Space Station is NASA's cornerstone for our human space exploration programs. And I say that because it is in low Earth orbit. It is only 386 kilometers, 240 miles up. So we can get there within about 4 hours from launch. It's a nearby capability for us to test out technologies and experiments that we're going to need information before we start doing a much longer trip to the Moon or Mars. So it is an orbiting laboratory, and it's in microgravity, which gives science just a unique opportunity to do all kinds of experiments, not just for NASA exploration, but for life on Earth as well. It's been continuously occupied since November of 2000. So that means the last time we've had all human beings with their feet on the Earth was over 20 years ago. We have had life on board, life in space, for over 20 years. It's an international partnership. We have 15 different countries working together on the space station, and we've actually had over 240 different astronauts and cosmonauts visit from 19 different countries. So there's a lot of opportunity there. I mentioned before it's in low Earth orbit, which is 386 kilometers up. And because of the size of it and because it is fairly nearby, you can actually see the space station when it goes overhead. At nighttime, it looks like a very bright star. And if you ever want to see the space station go over your hometown, you can go to spotthestation.nasa.gov. You put in your location, and it will tell you when's the next time you can see it. So this is what makes up the International Space Station. This long piece in the middle is the truss. It's the main structure, and it holds these 4 solar arrays, which provide 75 to 90 kilowatts of power for the space station. The living quarters are these modules you'll see on the sides. The modules on the left, the service module, the FGB, these were part of the Russian Space Agency. And then Node 1, US Lab, Node 2, Node 3 are part of the NASA group. The Columbus Orbital Facility is from the European Space Agency. And the Japanese Experiment Module and Logistics Module, as well as their exposed facility, are, of course, part of the Japanese Space Agency. In addition, we have this fantastic robotic arm, which I'm actually, it's part of the MSS, it's up here, which is part of the Canadian Space Agency. This is who's on board the space station right now. These 7 crew members represent 4 different countries, the Japanese Space Agency, the Russian Space Agency, NASA, and European Space Agency is Thomas Pesquet from France. So I did mention it's an international partnerships, which is key to any future explorations in space. We can't go it alone. It's a small world, and everybody has different needs. Everybody has different technical competencies. So we all work together to try to advance our systems on orbit. But in addition to those 15 countries that are part of the partnership, we are doing research and experiments on orbit from all over the world. And so you can see the countries in pink have done some sort of research or education project on board space station. It really is just a global enterprise. So as I mentioned, right now, there are 7 people on orbit that are working on board the space station. We've done over 3,000 experiments to date in areas of biology, biotechnology, earth and space science, human research, again, representing 108 countries. It allows us to do different scientific discoveries benefiting us here on Earth. And it's a test bed for us to develop new technology to go further in space and explore. There is NASA research. It is also considered a national lab. So we have the Center for Advancement of Science and Space that manages it as a national lab, and doing international research, of course, as well. So some of the experiments we've done, some of the things to tell you about. This is a closed environment. These people are living in these modules, and it's only about 900 cubic meters inside for 7 people. When you have another vehicle arrive, so you're changing out crews, you can have 11 people on board. And so you need ways to recycle your air and purify your air. And how do you maintain oxygen? We don't want to have to bring up supplies all the time. It's expensive, it's heavy. And we're trying to look at how you're going to go further out. You're not going to be able to pack all the things you need. We need to be able to recycle as much as possible. So the air regeneration, water is heavy and difficult to lift. So of course we want to recycle all the water we can. That means we pull water from the air. We have our air conditioning systems that will pull out the humidity, and then that water gets sent to the purification system. We also recycle the urine, which nobody likes to hear, but that actually isn't all that different from the water treatment on the ground. Carbon dioxide, everybody's exhaling. We need a way to get that carbon dioxide out of the air. Again, that transfers to some of the issues here on Earth about carbon dioxide levels and how do we remove some of the carbon dioxide from the air. There's also been many medical experiments, methods to improve treatment of cancers using microballoons. Because we're in a microgravity environment on the space station, they can grow protein crystals in a different manner. And so they're able to get more insight into some of these proteins, some of these bacteria, and come up with better ways to treat cancer, to develop vaccines. We're also looking at nutrition changes and the human body in space. In the microgravity, you're going to lose bone mass, you're going to lose calcium. So we need to find a way to combat that while the crews are only on orbit for 6 months, as opposed to a longer trip where they're going to go for a couple of years. And the other thing is that it does give us a really unique view of the Earth. We orbit the Earth once every 90 minutes. They're taking photos. It's a great way to monitor climate change, disaster areas. This was a photo they took of the tsunami in Japan. They took that from the ISS, looking at urban growth, so they can compare photographs over time. And it's just a really great research tool for some of our life on Earth studies. We're also looking at materials. Anything we're going to build to be in space long term, going to have to be tough. It's a very harsh environment. So there are a lot of experiments where they have panels of different materials and how do they degrade over time and what issues do you have. Fluids react differently because you don't have gravity. Your wet, dry vac on the ground will bring the air and let gravity pull the liquid to the bottom. That's not going to work in space. So looking at how fluids react and what does that mean to your machinery? What does that mean to lubrication? What does that mean to the way your motors work? Anything involving any kind of fluid, we need to understand how that fluid's going to react. Colloidal alloys test, binary colloidal alloy test, is looking at these sorts of things, liquid gases, colloidals, how do they react in space as opposed to on the ground? So that's the sorts of things we're doing now. A lot of it is aimed towards going further in space, going to the moon, going to the Mars. And how are people going to live? If they're on a planet, there may be a reduced gravity. But if they're on orbit, there may be essentially free fall. The systems are required. Again, we are looking at how do we maintain the oxygen levels? How do we recycle the water? We won't be able to ship up kegs of water regularly. They're going to have to be able to recycle as much as possible. And then how do we make up the difference? And we want to make sure all our systems are easily maintained. We can't be replacing pumps every 6 months. We need to have things that are going to last a long time and require little to no maintenance. At the same time, we want to make it reduce the risk as much as possible. And we want to be, of course, good stewards of the taxpayers and keep this within reasonable cost. So some of the things we're doing right now, crew systems, all the things to keep the people happy and healthy. That's the sort of things I do with life support, looking at emergency systems, looking at air recycling, looking at water recycling. How can we improve systems? The vehicles, how are we going to launch? How are we going to get to a lunar orbit? How are we going to get to Mars? And then mission operations. Here in Houston, we do have the mission control, but you also have a significant time lag when you're further in space. So how will that work? You won't have that communication instantaneously. So the NASA space policy is basically to continue operation of the space station in cooperation with our international partners and help develop commercial platforms to sustain our presence in low Earth orbit while we transition beyond that and beyond ISS. So we're trying to enable exploration. We're trying to do research to benefit all of humanity, looking at all those ground monitoring, commercial research, the experiments on board, maintaining our international partnerships. We love our international partners, and it's a great way to further us in space. And we're working with some of the commercial vendors, such as SpaceX and Cygnus, Northrop Grumman, who has the Cygnus vehicle, enabling the commercial low Earth orbit economy. So if you want to learn more about the space station, you can go to nasa.gov/station, and there are links there. You can learn about the crew. You can learn about where to see the space station going overhead. We're also on Facebook, Twitter, Instagram. You can find NASA on pretty much any social media there is. Thank you.
My name is Miriam Sargusingh. I also am an engineer at Johnson Space Center, NASA, and I am the system manager for the environmental controls and life support system for the up and coming Gateway. And so I have a presentation here discussing the NASA Advanced Exploration Systems program, of which Gateway is a part. And of which actually ISS is a part, as it's used as a test bed for many of the technologies that we're going to be using for future missions. Okay, and so the overall program that encompasses the Gateway and several other vehicles is called the Artemis program. Artemis is the sister of Apollo, so this is a continuation of humans' desire to explore, starting with the moon, but of course going beyond. And so we'll talk about the human landing system, the Gateway, other EVA activity, extravehicular activity, lunar terrain vehicle, exploration capabilities, and AES integration. For the Artemis program, we're going to the moon to learn to live on other planets and for the benefit of humanity. With the Artemis Lunar Exploration Program, NASA will put the first woman and the first person of color on the lunar surface and build sustainable presence there and in the lunar orbit. So our near-term exploration plans, and this is where we're very excited. Lots of stuff going on, both ISS as well as within the Gateway and HLS programs. First, we've got our commercial lunar payload services item. We've got, we're getting prepared for Artemis 1, 2, and 3. And this is where we are testing our capabilities to ensure that by the time Artemis 3 comes around, that we have a successful and safe mission to send crew to the surface of the moon and return them safely to the surface of Earth. Within that time frame, Gateway will be starting to be developed. So starting with the power propulsion element and the habitation and logistics outpost, or the HALO. So the HALO provides the first module that's going to be in lunar orbit where a human can reside. And then, as I mentioned, Artemis 3, this is where we actually have our crewed mission to the lunar surface. And finally, surface mobility. So we'll be looking at being able to expand our exploration capabilities on the lunar surface. So this is just a snapshot, and kind of excited, you know, at some point to see this Artemis base camp start to build out. And our advanced exploration systems portfolio, as I mentioned before, includes the Gateway as well as other exploration capabilities, our surface mobility systems, the human landing system, and the exploration extravehicular mobility units, or the XEMUs. These XEMUs are built off of a platform from the Apollo suits, as well as learning from the suits that were used to build the ISS. And so a lot of advancements were created in miniaturizing the life support systems to support one crew member going out and performing EVA, while the lots has been learned with regards to mobility. So this will be a much more mobile suit. There are definitely movies out there on YouTube that you can look at where crew are stuck on their back and trying to get up from after having fallen down. And we're very excited this suit is going to allow the crew a lot more flexibility to perform more science and not get into precarious situations. So the human landing system, this is an example of what a human landing system might look like. This is going to carry 2 crew to the lunar surface for the first mission, so for Artemis 3, and serve as a habitat on the lunar surface for a short duration of a little less than a week, and houses the equipment for surface activities. So we expect the crew to be able to go off and do the moonwalks and collect samples and return them to Earth. Gateway, which is where I work, is a multinational adventure as well. So NASA is working with the Canadian Space Agency, the European Space Agency, and the Japanese Space Agency, JAXA, to build this multi-module platform. This will actually be a platform. So the purpose of the Gateway is to provide a temporary living arrangement for humans. From here, or the Orion will bring crew from the surface of the Earth, bring them to Gateway, and then from Gateway, they can go down to the surface of the moon. And then in the future, I'm super excited about transferring crew to a Martian transit vehicle. They can go off to Mars and we can plant boots on a new planet. It's gonna be very exciting. So as I mentioned before, super excited about the advancements that are occurring with the extravehicular mobility units, or the XEMUs. Increased flexibility enables advanced sample collection, improved design accommodates a wider range of crew members. And so I think previously I would not have been able to be an EVA subject, and now I am. Not that I'm going to be an astronaut at all. And then additionally, specialized tools will ensure the quality samples are collected and returned to Earth. The Lunar Terrain Vehicle is another item that has been worked on for several years, a collaboration of robotics in understanding of our previous lunar terrain vehicles. Again, extending the exploration range for our moonwalkers, providing autonomous operations for when the crew is not on the lunar surface. And I would say the autonomy that we are working on across the board for all of the elements is something that I'm really excited about. ISS has started the way with providing a lot of systems that do not require necessarily manual operation and can be operated from the ground. And that's laid a preliminary background, and we're working on a lot of algorithms and software so that we provide more and more automation and autonomy so that the crew can perform general operations, but also identify when something goes wrong. They can do that, the anomaly investigation and repair on their own without necessarily needing ground support. And then finally, the base camp, which is going to be pretty exciting, although this base camp is really, again, so my heart is that I can't wait till we get to christen some Martians. So this base camp is definitely going to be a step towards the future. The regenerative life support system is going to be a key aspect to enabling future missions to Mars, as well as long duration missions on the surface of the moon. And this is one place where, well, one of many places where the ISS has given us a tremendous amount of experience. And the ISS exploration ECLIS group has worked over the last several years to advance the systems that are aboard the ISS and test out new technologies. So for example, we currently have CO2 removal systems that are being tested on the ISS, as well as new toilets that are more efficient and smaller and better use. And so the ability to test these systems out on ISS is actually invaluable. We definitely want to make sure that before the crew goes off and sets off for Mars for their multi-year mission, that they can rely on the basically the HVAC and the plumbing that we've installed into the habitat for them. So the first one, as I mentioned, the Universal Waste Management System, exploration class space toilet. This was just installed, actually. So I'm pretty sure that I heard that there's actually a lot of crew on the ISS right now. Is there 11 maybe? So I'm pretty sure that they're pretty happy to have a second toilet to make use of. We've got upgrades on our water processing system. So one of the things that we want to make sure we can do is make use of as many resources or reuse as many resources as possible. So one of those things is to recover water from wastewater. And so the two ways that we do that is we collect water actually out of the air. I don't know if you've seen your own air conditioners and you see the water dripping out of that. We collect that and process that so that the crew can recover and drink. And then also what goes down into the toilet, all that liquid, we want to recover that as well. Purify it, clean it up, and return it back to service. So I get pretty excited about this because these are areas where we can definitely transfer these technologies to better our own life here on Earth, making these systems more efficient, more safe, more compact. It would allow us to make life easier in water poor countries and areas. So our exploration capabilities development strategy, and a lot of this again revolves around the environmental control and life support system. So essentially extending the habitability and autonomy so that the crew can live longer and longer away from Earth. So first we've got Orion that can support 21 days. Our Foundation surface habitat will be able to support up to 60 days, and then enhanced habitation capability for 800 plus crew days. And this is what would definitely be needed in order to support a Mars mission. And this is a huge map. So we do have complementary ground tests and analogs. As I mentioned before, we are learning tons from the ISS. I think most of our time until we get to the Mars surface is going to be in microgravity. So making sure that our technologies are operable in the microgravity environment where there's no up and down or buoyancy to take advantage of is extremely important. Continued test beds on commercial platforms in LEO, as well as infusing technologies into the gateway. As I mentioned, we've got the toilet, the CO2 removal system, environmental monitoring, new exercise technology. So this is making sure that the crew can stay fit in that microgravity environment. Radiation protection and monitoring, medical systems, fire suppression and cleanup. And one thing I'm going to add here is food. So there are a lot of advancements being made in food. It's really important that, you know, months and months away from Earth, that the crew won't get bored of the food that they have, that they're going to be able to have a good variety of food, but also that it'll be able to fit in the cupboard. The human landing system is the same lunar surface, ECLIS, and crew health and performance infusion. Includes partial gravity and exploration atmosphere fire safety. So fire behaves funny when there's no gravity, and it behaves even funnier when there's half a gravity or a partial gravity, because it takes on the attributes of both terrestrial and microgravity movements and diffusion. So we'll be learning a lot more about fire safety and how to put fires out. So that the crew will be safe on the Mars surface as well. A lot of work to be done to work out kinks in exploration and extravehicular activity and surface ops. And then our pressurized rover will be probably, other than the suit itself, our tiniest habitat, allowing crew to move around basically their little personal RV moving around the surface plane. And then finally, our Mars class exploration, transport, and Mars surface life support and crew health and performance systems. Okay. So we are ensuring collaboration across teams to achieve mission success. Artemis 3 Plus manages the definition, certification, and operation of systems that will establish a human presence at the moon, and I would say and beyond. That's it for my presentation. It was really fast, so I welcome questions.
We hoped you enjoyed finding out a bit more about the International Space Station and the very exciting plans for the Lunar Gateway and beyond. I'm now extremely pleased to welcome both Miriam and Stephanie for a live Q&A. Please remember that you can submit any questions that you have for them via the YouTube chat. Hi, both. Thank you for joining us, especially given that the weather is apparently quite wild for you.
Hi, Nina. Yeah, it's calmed down, but we had some pretty big storms earlier today.
Good stuff. I'm glad you could both make it and your internet held out.
Yeah.
We've got a couple of questions, which we're quite excited to ask you. So I think we're going to start with them. So this is quite a good one. And actually, I think we could extend that a little bit. So Coral has asked, how do you decide who goes to the space station? So I suppose I can fire that at Stephanie. But Miriam, how are we going to choose the people that are going to the moon and Mars as well? So Stephanie, if you want to go first, we'll start in low Earth orbit and head out.
Sure. So there are NASA and ESA and JAXA astronauts, as well as Canadian Space Agency astronauts as well. So each agency has a selection program. I think they either just did or they're just about to put out another call where people can put in applications to join the astronaut class at NASA. Usually they get thousands of applications, and there's a very rigorous screening process. Some of it involving, physical health, because if you're going to be going on a long-term flight, you need to make sure there's not any issues. Some of it is psychological. Can you handle being locked up in a spaceship with 6 other people or 2 other people, or, for 6 months, a year? So there's a lot of different screening processes they go through, but once they've done that and somebody becomes an astronaut candidate, and then they go through training, and as missions come, they select a crew based on their skills, based on their strengths. They select a crew that will work together. And it depends on what that mission is. If we know that, during this mission, you're going to have to do several spacewalks, they're going to make sure we have crew members that are very good at doing the spacewalks. If it's a robotics expertise, well, who in the astronaut group has that kind of expertise? So they are looking at backgrounds. To become an astronaut, you really primarily they're looking at science, engineering degrees, with some exceptions. We have flown others as well. But yeah, primarily it's you get in to the astronaut class, and then they'll work out the timing of who's going on what mission.
That's quite exciting. And then Miriam, how are we going to decide who gets to go further?
Very, very similar. The trip to Gateway, as well as the trip to Mars. The Mars is very likely to be a multi-year mission. So it's very important that the crew is, and I think of the astronauts. I got to go to the induction of the latest astronaut corps last year, and it is just amazing the excellence that you see physically, mentally, and even from a character level. They're just amazing people. And as Stephanie said, it's a lot of training, a lot of understanding how they get along with each other, mapping those to the expertise that's going to be needed for the mission. And then the core will be developed. I think one of the things that is going to be very interesting, both for Gateway, the lunar surface, and for the Mars trip, is that we're going to have a lot of multidisciplinary people. We're going to have a lot of folks that are going to be able to think on their own. Basically, I would think a core of MacGyvers, a little bit of doctor, a little bit of mechanic, a little bit of scientist. And so I'm looking forward to seeing that set of folks. I have to say the latest, at least at NASA, core folks are absolutely fascinating. So it's going to be exciting to see who happens to come along.
It really is. Yeah, I like that whole core of MacGyvers. Lots of multi-talented people. So that's a really good question, Coral. Thank you very much. I think we've got our next question coming up. That's quite a good question. So Angel Ortiz has asked, do you lose your taste buds while in space? Does the water and food taste different after the processing of it? So Miriam, I think you talked a little bit about food, and particularly that for a kind of long duration mission. Would you like to field this one?
Sure. I'm going to give a little bit to Stephanie with respect to the water, because I know it does taste a bit different. And even depending on which processor makes the water, it tastes a little bit different. But there is actually a bit of research that's going on right now to study food fatigue. You don't lose your taste buds, but I think maybe the
it's different
availability of water of food makes it a bit challenging. I know one of the astronauts, Dr. Pettit, he would make this something called Boy Scout surprise, and his kids said that it basically proved that you lose your taste buds when you become an astronaut. but I think it's they are working a lot to incorporate a lot more variety in the food, to incorporate foods of several cultures in order to honor the backgrounds of the astronauts that are going to be on the missions. And again, just to mitigate that food fatigue, where the crew is going to be able to get all the nutrition that they need and not just go, eh.
And just to add to that, we have heard reports from some crew members that one of the effects being in space, they don't lose their taste buds, but they seem to need more spices. So we can't, of course, have a salt shaker or a pepper shaker, but what we do is we have it in liquid in like a squirt bottle. And taco sauce is a big hit. Everybody likes to, squirt taco sauce on their things. So I guess things taste more bland. And I'm not sure if that's a change in people's metabolism on orbit, or if that's because the food has to be, packaged and reheated. And so several of them have said that, yeah, they add more seasoning to things on orbit.
I've definitely heard that from a couple of astronauts about the need for spicy food, and it's partly related to the kind of what's it called, puffy face bird leg syndrome, where the fluid kind of drifts up to your face and it's like having a cold, so it's like sort of eating when you're unwell. I think we've got another couple of questions I think are loaded in.
Yep.
I think we're going to he's going to send them over. There we go. So this was actually a wee sneaky one that I put in. So Stephanie, you've worked for NASA for over 30 years, keeping astronauts safe and comfortable on orbit in a sort of variety of different ways, from kind of EVA tools to you worked on the Russian integration and also on sort of safety, emergency hardware and things like that. You must have come across quite a few challenges in that. Oh no, that's the wrong question that's come up.
Nope.
There we go. You must have come across a few challenges in that time. Are there any that you think are especially memorable, or you thought really you were delighted when you solved them?
Boy, on the spot here. Well, one of the things I worked on for several years, and everybody always wants to know about, is the space station toilet, which is the one we have on the space station right now, and they are developing a new one that Miriam mentioned, the Universal Waste Management. But the space station one, the Russians already had a toilet that worked in space on their Mir space station. And so we had started to look at developing one, and then said, they've got something that works. Let's just get the pieces from them, and we'll, put it on our side and convert it. And so getting the Russian hardware integrated into a US rack and the US systems was an interesting challenge. But again, you have engineers from all over the world, and we work great together. You don't worry about the politics. What is it we need to do to solve this problem? And so we were able to get that system working, and then we integrated it to a processor that would recycle the liquid into drinkable water. And we ran into a problem because all the tests we did on the ground, we did with donor liquid, shall we say, from people on the ground. And because when you're in space, your metabolism is working a little differently, and people lose calcium when you're in microgravity, and we have to have them exercising, and they're losing calcium, they're losing bone mass. That came through in the urine, and that affected our processors to the point where things started to break because the calcium was reacting with some other chemicals, and yeah, it was causing problems. And so it was just interesting that, none of us realized, we couldn't figure out why this worked so great on the ground and not in microgravity. And then when we found out that what was going on, so finding a solution to that was really interesting. And we were able to change up a few of the chemicals we used to treat the system, and it's all working great now. We're recycling, I believe we're at 85%. So we pull of the liquid we get 85% of the water out of it, and we're trying to get that number even higher with other processors, so that we don't have to bring water up, and that's going to be very important for going somewhere further away.
And I'm
That
sure
was pretty
the
cool.
astronauts are delighted to hear that as well. And I do believe that the water on the space station, after it's gone through the processors, is actually cleaner than the water that comes out your taps at home. So
That's what I'm hearing. Yep.
something going right. So I think there's a wee question about lunar dust that Abby's going to fire over. Yep. There we go. So Miriam, this one's for you, I think. So lunar dust is incredibly abrasive, sort of notoriously abrasive, actually. It's kind of like sort of ground sharp glass, and it's harmful to both equipment and to humans, to the crew, to their lungs particularly. What measures are in place to stop that entering permanent either surface or orbiting habitats?
So for the Artemis program, there's been quite a bit of attention placed on mitigating lunar dust and entry into the habitable environment. And it starts from outside. So with the EVA suits, they're looking at materials and properties of materials that would not necessarily repel lunar dust, but limit the attraction. So the lunar dust does have an ionic quality to it that causes it to stick to things. So they're looking at materials and coatings. And then there's also tools. So looking at even how to enter the lunar lander after an EVA, sort of having a porch where you dust yourself off, something similar to a lint roller to pull off as much dust as possible. And then possibly having, once you're inside of the lander, having a vacuum cleaner and the crew would vacuum each other off to move some of that dust as much as possible. Within the air revitalization system, we are evaluating the effectiveness of our HEPA filters, the high efficiency particle, let's see, I lost the P and the A. But the HEPA filters, similar to high efficiency vacuums, will remove most of that dust. And we're also looking at new technologies, maybe a cyclonic filtration in order to move that dust and capture it, so that way we can limit as much as possible. We're also looking at doing testing to evaluate what the long-term effects of the dust might be on hardware, since Gateway is going to be there for 15 years at least. We want to make sure that we understand what the cumulative effects will be of that lunar dust as it sort of stays within the nooks and crannies of the station itself.
We're going to have to send all the astronauts up with dustbusters or something like that to get
yes, really.
I think we've got time for one more question. So we'll read it out. There we go. So DJ DB Extreme says, "Hi guys, loved your presentations. I host an Inspiration Hour show on Sunny Govan Radio. That's one of our fantastic local radio stations, which is a strong supporter of GSC. He's not wrong. Do you have any music requests you'd like him to play
Well, I don't know what kind of music you usually play, but I am a 80s new wave fan. I've got to say, David Bowie. Starman.
That's the ideal choice. Miriam, anything from you?
Oh no, I don't have one off the top of my head. I do love Queen.
Yes.
Just about any song will do.
That sounds amazing. Well, DJ DB Extreme, thank you so much for that question, and we're looking forward to hearing Miriam and Stephanie's picks next week.
Wonderful.
I'm afraid that is us just about out of time, so I'd like to say a massive thank you both to Stephanie. Oh, no, got one more. Sorry. I'll grab that up in just a second. There we go. Oh, right. Greg Davies has asked, as engineers, we want to find solutions to real-world problems. What solutions do you hope to find through space exploration? That's quite a big one.
Miriam, do you?
Well, so I would say that one of the things is I've been very intentional about my career in sticking with life support systems. I think the work that we do is actually translatable to here on Earth. I'm happy to be part of projects that help us to recover water more efficiently, particularly for areas of water and lack of clean water become more and more prevalent. I think that's going to be extremely important, and even air revitalization. So being able to use those technologies to make our lives better in our residential environments. So I think that just applying those technologies to life here on Earth is really what is fulfilling about my job.
And yeah, just to second that, that was my first thought, but I wanted to let you get a word in first. Carbon dioxide is a big discussion point right now, and a lot of what we're dealing with on the space station and on future ships is how do we remove the carbon dioxide from the atmosphere? What can we do with it? How do we, clean the air? So that is something that we're hoping, these technologies, as we're looking at several different ways to do it, is that something we can be using on the ground? And then the other part for me is also some of the medical advances that are being done. They're finding new ways to treat cancer, new ways to treat diseases, develop vaccines. So we don't even know what we don't know yet. And all the medical research that they're doing on board is just fascinating to me. So.
I think
Okay.
we always remind people that the motto of the space station is off the Earth, for the Earth. And I think that
Yes.
both summed that up kind of really perfectly. And I think Artemis has been really useful for that too. That is definitely us for this evening. We are out of time. I'm sure we could have sat and chatted about this for ages, but I'd like to thank you both, Miriam and Stephanie, for joining us today, and to thank everyone watching as well. Please do stick around for Curious About Innovation. We're going to be running Thursday and Friday. If you've got any other burning questions, please do send them to us at the Planetarium Twitter, which is at GSC Planetarium. But it's just left for me to say thank you all and good night.